Hi, Peter and Isabel back again with another tutorial on Tinkercad. We're going to be looking at the circuit section again, and this is really the first project that you would start in Tinkercad to design and learn how to code, how to do the design, how to do all the prototyping.
Okay, so we are going to log in our email username, going to our email and password, and next is gonna be the main screen of Tinkercad. So this one is the main screen of Tinkercad. We are gonna be using circuits, and let's create a new one. So we are gonna start our first project. So search area is gonna be our first thing to work with. We need an Arduino Uno, and click and drag to the left, placing it in the middle of our screen. Then we are going to look for the breadboard. Placing this one under the microcontroller. And since the project is kind of big, we are going to zoom it a little bit. So we will have space to the wiring. The next are going to be the components. We have an LED, and the resistor. So before placing them on the breadboard, it's important to change the values. So the resistor is going to be 220 ohms. And the LED, we can leave that color or we can change it. So the next thing is going to be to place the components on the breadboard. So this LED, we need to check the connections. We have cathode, we have anode. So in case of the cathode, cathode is a connection to the ground, which is the negative, or the blue section of our breadboard. And this one has to be protected using a resistor, in this case a 220. And then we have a second leg, which is the anode, and this one is the connection to our microcontroller. So as soon as we have the cathode connected, the next thing is gonna be the connection of our anode. And this one is the right leg. And as you can see there is a vertical pins all in green. So we can connect the cable in one of those green pins. So dragging a pin from here to the number 2, we are going to use the number 2, which is the digital side of the microcontroller. And then we are going to change this one to red so we can match the color of the cable with the LED. There is a last cable that we need, which is ground. Since the microcontroller has ground, we are going to click and draw a cable to the blue section of our breadboard, changing the color to blue. So that way we have ground to all the pins of that section.
Now you might notice on the microcontroller there are actually 3 ground pins. There are the 2 over on the power side here, and there's one actually up here on the digital side. You can use any of those grounds to create a ground connection on the cathode side of your circuit project. So we could have used any of those.
Yeah. So the next thing is gonna be changing the name of our project so we can register that in our files. Very good.
Oh, helps to spell project right.
So as soon as we have the new name for our project, the next thing is gonna be the coding. Let's go to the text section and continue. We have there the sample that we are going to use. If we start the simulation, just to make sure that the two LEDs are working. So taking, yeah, orange and green, both blinking. So
We're good. No short circuits here.
right.
All right. So we're going to stop the simulation and say goodbye to the test code.
Yes, this has to be erased because we are gonna type our own. Very good. So in here we are gonna start with the integers, and those are the connections to our microcontroller. In this case is the number 2.
And what I'm going to do is increase my screen size a little bit so you can see the code better.
Excellent.
And then I'll resize here. So again, we can see the code a little bit larger
and the project
at the same time.
So the next step is gonna be the void setup. Void setup, we are including in here if it's an input or an output. In this case, we have output. So it's important to declare that. So it's gonna be pin mode. We have an LED as an output.
Do the capital letters, lowercase letters make a difference?
They make a big difference. Like in case of pin mode, in there we have a capital letter in the middle that indicates that we have 2 words.
All right, so we've done the integer LED equals 2. That's a variable. That variable is assigned the value 2. The 2 actually will come down here and be placed in that pin mode statement. So it's a nice way, if we want to move the wires around, we could just change the number and go from there.
So the next one is gonna be the void loop, which is the function of our components inside the circuit. So we will need parentheses and bracket for typing the first sentence, which is gonna be a digital write LED. And the word high means that the LED is gonna be on. And then we need to give a time between high and low, or on and off. In this case, we are going to use timing of 500, and 500 means milliseconds.
So that's half a second.
Yes.
500 milliseconds is half a second.
Yeah.
Ah, very, very cool.
So if we are going to have a digital write in high, we need digital write in low.
And there's one of those pesky capital letters in the middle of a joined word like that.
Yes.
And we see here the LED, we're using that variable again. And now we're going to do low and that.
We give another delay, so okay, we separate the 2 commands. Important to close the sentences with a semicolon, and the void loops, void setups with brackets.
Yeah, we have the lines, each sentence,
yes,
ending with a semicolon.
Right.
I don't know how many times we see that. We do it ourselves. How many times beginners always forget the semicolon, or they put in a colon.
Yeah, those are common mistakes. So that's why we have started with a simple code, so we can check the possible mistakes that students can make.
Okay, so what's next? What do we do?
So the next is gonna be starting the simulation. So we are gonna see how the project works. So in here we will have an LED blinking. It's gonna be kind of slow because of the timing that we gave. The challenge is gonna be to change the delays, the timing to less, and then we will see a different way of blinking. the LED. So we can use 100 to see how the project works.
Almost too fast for the screen. It's just wiggling a little bit.
Yeah.
So 100 milliseconds for
It's,
this simulation is pretty fast.
it is, yeah.
Okay.
The good thing about this code is that you can add more LEDs using this as a base, just the addition of lines. Is very, I mean, it's easy for students to understand how the void setups and loops work.
So we'll increase the speed or slow it down actually. We're going to add longer delay. But if we add it in, we can copy the code. This is great here. And we can paste new code here. And if we made this half a second, now we should see kind of a variation of the blinking.
Yes. Yeah, the delays are going to change the timing. Just another
Interesting.
pattern.
Not a different pattern.
Yeah.
Very cool. Well, that concludes the first project. Pretty straightforward. You have a couple challenges here. We suggest that you play with, basically you're innovating now, the patterns that you would see with this single LED. Change how fast, how slow, you might want to blink it, change the patterns.
The patterns, even adding more LEDs.
Thank you for watching our video, and we will see you in the next project, multiple LEDs.